Okay, kiddos. So I just spent about 40 minutes working on this, and then it like froze and erased my the video. So I'm gonna go through this, try and keep my patience, try and remember all the hilarious jokes I told, all the wonderful insight, all the heart-wrenching moments that truly made this the best video ever. Or I could just like go over the math, whatever. So, what we're doing is this review. So the first part, basically what we have here is, so like, I know I'm jumping around, sorry for that, but how I expect people to use this video. This video is not, excuse me, a substitute for doing the work. This video is so that if you need help and I'm not there, you can do that. So try the problem. If you don't succeed, watch the video. Pause it, rewind it, watch it again. If that still doesn't work, email me, whatever, and we'll get through it. So, I'm going to, in order to hopefully avoid what happened last time, we'll probably be doing these in like little half-hour videos. So it'll be part 1, part 2, part 3, part 4, however long it takes. Okay, so segment addition postulate. So if I had a guy, right, and he walked from here to here, and then over here he had to drink water, and then he continued walking over here. So walked from C to E, and then he walked from D to E. The total distance he walked would be x plus 3. So what we do here is we go from C to D is 3, from D to E is -7 plus 2x, and the whole distance we know is x plus 3. So that turns into 3 minus 7 plus 2x equals x plus 3. And then we have to solve for x. Because ultimately, when they ask us to solve for D to E, we need to find x, plug it into right there, and that's going to be our answer. So that gives us -4 plus 2x equals x plus 3. We want to combine our like terms across the equality sign. First thing I like to do is get my variables together. So it's -4 plus x equals 3. If you don't like this, guys, you can also write it as x minus 4 equals 3. It's the same thing. Add 4 to both sides, and we get x equals 7. Now, I know that I have to put a 7 in right there. So we go -7 plus 2 times 7. That's -7 plus 14 equals 7. Okay, like, so if you guys don't believe me that I already did all this, like, this is, and I started erasing it, but that's all the work. Look at that, like, gorgeous, right? Here, let me even show you. I drew like the fanciest 4 ever. Because I know this is why you're watching the video, is to see me scroll through looking for a 4 that I wrote. I got a little carried away with the galactic pen there. Yeah, I don't know where it is. Anyway, it was a super fancy 4. It was the fanciest 4 ever. And now it is just relegated to nothingness. Anyway. Number 2. Same idea here. We're going to go x plus 1 plus 2x minus 12 equals 10. We add the top 2, and they equal the bottom 1. Combine like terms. 2x plus x is 3x. 1 minus 12, -11. Add 11 to both sides. Get 3x equals 21. Divide both sides by 3. and we get x equals 7. Now we're looking for QP right there, so the 7's going to go right there. So we go 2 times 7 minus 12. That's 14 minus 12, or 2. 2's our answer. Now if I want to check that, if I'm like, I'm not sure about that, plug the 7 in right there. 7 plus 1 is 8. 8 plus 2 equals 10. The total distance is 10, so that checks. Again, we add the top 2 to get the bottom one. 2x plus 4 plus 3 equals x plus 7. That gives me 2x plus 7 equals x plus 7. Subtract x from both sides. That gives me x plus 7 equals 7. Subtract 7, and lo and behold, I get x equals 0, which none of us like. Now I'm looking for SU right here, so I'm going to put a 0 right there. 0 plus 7 is 7, so 7's my answer. Now, if I want to check that, I'd put a 0 right there. 2 times 0 is 0. 0 plus 4 is 4. 4 plus 3 equals, everyone together, 7. Yay! Okay. Again, add the top 2. Get the bottom one. 6 minus 6 is 0, so we get 2x equals 3x minus 7. I'm going to subtract 3x here. So we get negative x equals negative 7. Okay, so what this is, that negative is really like a negative 1 times x equals negative 7. So I'm going to go ahead and divide by negative 1 because we don't want to know what negative x is because we're looking for LJ. So we're plugging it in for x. We're not plugging it in for negative x. So we got to find x. X equals 7. 3 times 7 minus 7 equals 21 minus 7 equals 14 is our answer. And it's just raining cats and dogs outside. Okay. These are the same general idea. So we have yellow and blue make green. So if we add up the two inside angles, we get the outside angle. How do you set this up? Well, how many more colors are there? I mean, I know how many more colors there are, but I was just wondering. They don't have any, like, fancy colors here, though. Notice they only give you, like, one white and black. Their grayscale is pretty limited. Anyway. So, we know that those inside two have to add up to the outside one. So if we know what this outside one is, so that's JIH. So we know 96 right there. So we know when we add them up, they're going to be 96. So this is how I'd recommend that you set them up. You figure out what that big outside angle is, set it to the right of the equal sign, and then you can just say, okay, well, the other two, I just add together to get the big one. 2x plus 106 equals 96. Subtract 106 from both sides. Now, a lot of you guys might not be comfortable with this, but the fact is that it's totally okay for x to be negative. We can't have a negative segment length, we can't have a negative angle length, but we can have a negative x. The question asks us to find EIH, and it's not like the measure of EIH. So we know the measure of angle EIH is x plus 51. So if we plug a negative 5 into that, our answer is still a positive 46. So even though we had a negative x, we had a positive angle. Sipping my coffee, staying awake for you guys. TSR. TSR is 41x, so we know this adds up to 41x. Add the other two, 64 plus 25x. Subtract 25x because we got to put our like terms together. and we get 64 equals 16x. Divide both sides by 16, and we get x equals 4. Okay, now we're asked to find TSR, the measure of TSR. So we go 41x, we know x equals 4. So we're going to go 41 times 4, or 164. And that's our answer. Big outside angle, IJK, 117. So we put that out here. We know they have to add up to 117. So we have 5x plus 19 plus 2x plus 21 equals 117. 5x plus 2x, 7x. 19 plus 21, 40. We're going to subtract 40 from both sides. We get 7x equals 77. Divide both sides by 7, and we get x equals 11. Now remember, let's look what, we have to find MJK. MJK is 2x plus 21. So we go 2 times, we're going to plug in that 11 that we just found. We're going to get 43. Here, big outside angle, PQR. PQR equals 150. So we add those other two together. Okay, 21x plus 6x. Notice that I switched those two around. I hate lead negatives, personal pet peeve. And switching them around is just the commutative property of addition. Totally okay to do. As long as you keep the negative with the 6 and the positive with the 21x. So, 21x plus 6x, 27x, negative 6 minus 6, negative 12. We're going to add 12 to both sides. Get 27x equals 162. We are then going to divide both sides by 27. And we're going to get x equals 6. It's asking us to find IQR. We know IQR is negative 6 plus 21 times 6. That's negative 6 plus 1, 26, or 120 degrees. So, 9, 10, 11, 12, all these ones. So notice what it's doing here. It's asking us to find the parallel and the perpendicular lines. Go through your notes. You remember that parallel lines are the same. Perpendicular lines are the negative reciprocal of each other. So if we have A over B, that would go, so it's opposite reciprocal or negative reciprocal. So we change the sign. It becomes negative A over B. And then we flip it upside down. It becomes negative B over A. So that's how you do perpendicular. Now all of these that they give us are in y equals mx plus b. That's slope-intercept form. Where this bad boy right there, that's the slope. So our slope is going to be the number that's in front of the x. It's called the coefficient of x. So here, it's 3/4. We know that the slope of lines parallel to it, notice what I did, slope parallel, equals 3/4. You can also say parallel 3/4. That's okay too. So for perpendicular, we're going to take that 3/4. We know we need the opposite reciprocal. So the opposite is going to be negative 3/4. We just changed the sign. The reciprocal, negative 4/3. So the slope of any line perpendicular to this line is negative 4/3. And that's it. That's all we have to do. We actually don't worry about that y-intercept at all right now. We're only focusing on the slope. So number 10, our slope's negative 2. Parallel super easy. We just copy it down. Hey, Cleo. Perpendicular slope, a little bit tougher because negative 2. So we can do the opposite. We get 2, but then how do we flip it upside down? Well, we remember that that's a 1 right there. So when we do the reciprocal, that turns into positive 1/2. Next two are basically the identical ones to the two we just did, just with different numbers. So our slope here is -3. So the parallel slopes are going to be -3. And the slope of any line. What's up, Cleo? Oh, is that true? Slope of anything perpendicular is going to be positive 1/3. We took that -3/1. We changed its sign. And I know. See, the cat's really impressed by all the math we're doing. She says, wow. Here we have 3/5. So the parallel slope is also 3/5. Perpendicular slope is going to be -5/3. Take that 3/5, turn it into a -3/5, flip it upside down, -5/3. Okay, a lot of people are having trouble with this, so I'm going to kind of walk you through why this works. If I have this triangle right here, and this is A, B, C, and the angle D. I know that A plus B plus C equals 180. I know that C plus D equals 180. The first one's true because I know that all the angles inside a triangle add up to 180. The second one's true because if this is a straight line right here, then that's a linear pair. Linear pairs are supplementary. Supplementary angles add up to 180. Well, if they both equal 180, so an A plus B plus C equals 180. Now the 180 equals C plus D. Because they both equal 180, they equal each other. A plus B plus C equals C plus D. Subtract C from both sides, and I get A plus B equals D. So that means this is the exterior angle theorem, should be in your notes. And it says that the measure of the exterior angle is equal to the sum of the two remote interior angles. So how does that play off for this one, number 13, where we're looking for angle R? So again, once we solve for x, we're going to plug it in right there. But first we have to solve for x. So we're going to go the two inside angles add up to the outside angle. Combine like terms, and then what we're going to do is I'm going to subtract 8x from both sides. That gives me 48 equals 5x minus 12. I'm going to add 12 to both sides. And I get 60 equals 5x. Divide both sides by 5. And I get x equals 12. Okay, so now I go back, plug that 12 in right there. So now the measure of angle R is 8x minus 12. I know x equals 12. So I go 8 times 12 minus 12. 96 minus 12, or 84. Same thing for number 14. This time we're looking for u. So once we find x, we're going to plug it right there. So we add those two inside angles, 3x plus 10 plus 6x plus 16 equals 116. Those combine for 9x. Those combine for 26. 116 is 116. We're going to subtract 26 from both sides. And we get 9x equals 90. Divide both sides by 9. And we get x equals 10. We're looking for that right there. So we know the measure of angle u equals 6x plus 16. We know x equals 10. So we're going to plug that bad boy in. And we're going to get 16, not 16, 76. And that's our answer. If I wanted to check that, I could plug the other x in. 3 times 10 is 30. 30 plus 10 is 40. 40 plus 76 is 116. So our work checks out. Here we go, 8x plus 20x equals 140. 28x equals 140. Divide by 28. And we get x equals 5. Now we're looking for angle B. So we got the measure of angle B equals 20x. We know x equals 5. 20 times 5 equals 100. Here we're looking for RUV. So when we have RUV, that's direction. So that R to U, U to V. So when we have angle RUV, it centers on that center one, and the R and the V are kind of the directions. Why can't we just say angle U? Because we wouldn't know whether we're talking about this angle right here or this angle right here. So we know that 28 plus 7x plus 22 equals 10x plus 14. Combine like terms, we get 7x plus 50 equals 10x plus 14. And subtract 7x from both sides. And we get 50 equals 3x plus 14. Subtract 14 from both sides. And we get 36 equals 3x. Divide both sides by 3. We get x equals 12. We're looking for RUVs. We're going to plug that 12 in right there. We're going to go 10 times 12 plus 14. 120 plus 14, or 134. Okay, so let's go over what our options here. We need to state whether or not they're congruent. So our options are side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. If it's not one of those, we can't prove it congruent. So what we do is we kind of label everything. We know that this is a common line right here. So that's a side for both. We have our angles for both. And we have a side for both. So over here on the left-hand side, we have that side, angle, side. We have the two sides and the included angle. Unfortunately, over here, we have as. This angle right here isn't in the right place. In order to prove congruency, it would need to be right there. So I say, not enough information. Could they be congruent? Sure. Do I have the information to prove they're congruent right now? I do not. So let's look at number 18. Okay, number 18. So here we have a side and a side. These two sides match up. These two sides match up. So now we're in an angle. And I go, hold on a second, I remember these little bow tie angles right there. Side angle, side. Side angle, side. So we say yes by side angle, side. So moving on to 19. Notice we got an angle here. We got an angle here. And 90-degree angles are always congruent. So we have three angles. Now notice, none of our postulates or theorems allow us to draw congruence with three angles. We can draw similarity. If you're in the honors class, you know what that is. So we can say, not enough info. Again, why are we saying no instead of not? Why are we saying not enough info instead of no? It's because they could be congruent. We just can't prove it. Okay, so here, number 20, we have a side and a side. We have the shared side right here. So that's a side and a side. And then we have an angle. Now normally we go, uh-oh, SSA or ASS, that doesn't work. But here, these aren't just any sides, guys. These are special sides. Why are they special? Because of this. Because this is a 90-degree angle, this just isn't any side. This is the hypotenuse. as is this. This isn't just any side, that's the leg of a right triangle. So now we have hypotenuse leg. Hypotenuse is the long side of a right triangle. It only shows up in a right triangle. Here we are again. We have these little bow tie angles, these little vertical angles. Vertical angles are equal. We're already given another angle that's equal. And then here we have our sides. So we have angle, angle, side over here. Angle, angle, side over there. In the same order. That's really important. Order matters when we're doing congruency statements. So here we have yes, angle, angle, side. 22. 22 is just like 18. We got our sides here. We got our sides here. And we have the vertical angle in the middle. So we say yes, side, angle, side. See how here the A is in between the two S's? Here again, the A is between the two sides. If it's not in between the two sides, we can't use SAS. Here, just like number 19, it's 3 angles. And moving on. 24, we have an angle here and an angle here. We have an angle here and an angle here. And then we have this tricky little shared side. So notice we have the 1 angle up to the 2 angle and over to the side. Can we duplicate on the other triangle? Sure can. 1 angle down to the 2 angle out to the side. So we say yes, angle, angle, side. Okay, so this first video is numbers 1 through 24. I'm going to stop it, get right on it, and make the next one.